companies in Hong Kong, one in China, and 2 companies in Spain.
Well, please, good afternoon. Please, we are waiting. I think just we are the people attending are here. Welcome to the next section. Today is a different day with a break before the student project, and also later is the last session student project before to send the poster. And really, it is an honor and pleasure to introduce you Luis Seco. Is professor of mathematics in Toronto University. He is responsible of sustainability of the Fields Mathematical Institute in Toronto and director of the Field Mathematical Institute in Shanghai. And Luis has really a long career and really a high reputed scientist in the area of artificial intelligence, mathematics and finance and sustainability. In the last year, he focused the work in the area of sustainability. We co-organized, in fact, a workshop. Last year was the first year. We are organizing now next one, sustainability with AI in the middle of sustainability that we organized with the Royal Academy of Engineering and the Adia Lab in Madrid. And this next year, together, his research institute, Shanghai Research Institute, Fields of Mathematics. Really, I am sure that all us will enjoy with his talk. It's really, I am sure, and my experience is a fantastic experience listening. Luis, thank you very much, Luis.
There's one thing missing, which is in my bio. There's one thing missing. There's 2 things missing. One is I have a lot of friends in Granada, and second, I have a lot of friends in Abu Dhabi. Okay, so with that, my description is more or less complete. Today, I'm talking about the future. And the reason I'm talking about the future is because the future is yours. The future is about sustainability. That's what I will be talking about, but I want to do it from a very practical perspective. My intention is not to do science fiction. My objective is to show you what the future might look like so that you can go and change it and make it better. And to be very precise about what I mean, I'm going to talk about money. What I have here in front of you is a graph of money. There's 3 amounts of money there. The first one, if you look at it from the right, is the GDP of Spain. It's about $1.5 trillion. Then you have the GDP of the Emirates. It's about $1 trillion. And then you have the AUM of Adia. It's about $1 trillion. And that looks like a lot of money. Let me show you another one. This is the GDP of the biggest countries on earth. The United States, GDP of about $30 trillion with a T. Looks like a lot of money. Germany 5, India 4, China 20. Big numbers. Okay, can they get bigger? Everybody's talking about gold. Gold is at the highest value ever. What's the value of all the gold on Earth? And by on Earth, I mean above the surface and below the surface. I only take into account the gold that we can mine. I'm not talking about the discarded molecules of gold which are mixed with that. We don't know. But we do know how much gold there is still in gold mines that we can take. So let me take that out and add to the gold that we have on Earth. And it's still also a very big number. It's almost $30 trillion. It's a lot of money. Can it get bigger? It can get a lot bigger. if I look at the price of all the oil that exists on Earth, and this is below ground and above ground, the one that we have extracted and the one that we still know is there, is big. It's about 200 trillion. By the way, this is why we have so much problems in the world. But that's a different talk. Different talk. All right. Now, the thing with oil, as you know, is we use it and then it goes down. All right. Can I get this number to be bigger? The answer is yes. And for that, I'm going to do with you a calculation. It's a calculation I want you to understand. What I'm going to do is I want to do the following. I'm going to calculate the following number. We receive energy from the sun continuously on planet Earth. We know how to turn that energy into electricity. We know the value of electricity. It's about 10 cents a kilowatt hour. How much is that? It's $400 trillion per day. I want to reflect on these numbers because there's very much to say about this. How did I do this calculation, in case you don't believe me? There's a fundamental number, which is right now electrovoltaic energy can be produced at the rate of about a kilowatt per square meter. It's a number. Engineers will give it to you. So we know the surface of the Earth. I have it there. I can multiply by the amount of the capture ratio that we have from the energy from the sun. This is high school mathematics. You can do the multiplications yourself. And the result is the number I gave you. Okay? It's about $17 trillion per hour. So we're creating a new China every hour. Sorry, it's a theoretical number. We could create a new China every hour. Now, why am I telling you this? Am I proposing that I cover the whole world with the electric? No, I cannot do that because, I mean, amongst other things, we need the sun for food production, amongst other things. I just want to talk about money for a little bit. I want you to understand the order of magnitude of what we're dealing with, because sustainability cannot be understood properly if it's not from this perspective. Okay? I will talk about AI, don't worry, okay? I'm coming. But first, I need everybody to understand sustainability. And for that, what I want to do is I want to talk about this wonderful asset management system that we have. We call the Earth. I want to talk about, because the Earth, in case you don't know, the Earth does not need humans. The Earth does not really care about climate change. It's dealt with it for a long time. Okay, we care about it. The Earth does not care. So I want to think of the Earth as an asset management system, because the Earth does manage all those assets. The Earth does manage the sun radiation that goes into the Earth, that turns into heat. That heat, because the Earth has water, creates rain. That rain creates food that then turns into biomass. And by the way, we also like the food because we can eat it. But this is the human perspective. The Earth does not care if we have food. The Earth just does what it does. Okay? And that's the Earth. When I talk about the humans, what do the humans, this is the Earth managing itself. How do the humans manage the assets of the Earth? We manage them differently. The humans manage the assets of the Earth in a different way. We want electricity, so we figured out a way to create electricity. We can do it from the sun directly. We can create it from potential energy stored in the form of a dam, or we can get it from that biomass that has accumulated over billions of years that we can manage, and that's where the oil industry comes from. This is the humans managing that. Now, I teach finance, and I teach investments. And some of you are from IDEA, I suspect, and that's what you do. You manage investments. So how can we understand how these things are managed? From an asset management perspective, there is a way to understand this, because the extraction of electricity from the sun or from water or from wind is what in asset management we call active management. Active management is an activity that just gives you value all the time. And then we have what you would call central bank reserves. This is the energy that has accumulated over billions of years, stored in the form of fossil fuels that you use because it's there. We have a lot of energy accumulated. All those, what was that, $200 trillion worth of oil? It's actually insignificant because we've been accumulating energy at a rate of $400 trillion per day for billions of years. You can do the multiplication. It's an insignificant amount. It's a little bit of energy that the Earth has managed to save for us so we can use it for a while. Okay? All right. So the question I want to start with today is, how would an AI agent do it? We've seen how the Earth does it. We've seen how humans do it. How would AI do it? I want to leave that question hanging. I'll answer it later. Okay, but I'm going to leave the question hanging. You understand what I'm talking about? Okay, how can we deal with this knowing that now we have AI, and therefore with AI we can do things better? All right, now I've talked about that. Before I answer that question, I want to talk about another element. See, energy is something that is very expensive, when in fact, at the same time, it's free. I want to talk about water, because water has the opposite characteristic. We think it's free, it's everywhere, yet, as you will see, it's very expensive. And what I have here is a well-known paper that some of you probably have seen. And it is a paper that analyzes the use of water to train AI models. And you may have seen that paper. You may be aware of this. Now, I'm not going to, don't rush to conclusions from what I'm about to tell you, okay? So I point to you a number which is there, which is the amount of water that training GPT-3 required. And that number is 700,000 liters. Now, do you know how much 700,000 liters is? Who thinks that's a lot of water? Who thinks that's hardly any water? You don't think. Okay. No, that's okay. You have an agnostic perspective on this, and that's very important. Because I suspect I've managed to convince you that we don't really understand this. I don't think we understand the value of energy, as I think I showed you, and I don't think we understand the value of water. So to understand that, let me introduce a very strange unit to measure water. Not by liters, not by tons, but I'm going to use the following unit. It's the annual consumption of a person, not by drinking, no. The annual consumption of a person by eating meat. Who eats meat here? Who is a vegetarian here? Thank you. I'm going to, what's your name? All right, I'm going to use you, if you don't mind, okay, as a very good example of unit measurement. The average consumption of water, because we eat meat, is about 100,000 liters per year. Except, Aurel, you do not. You consume about 100,000 liters of water less than any one of us. So if we want to understand the water consumption of GPT-3, which is, what was that? 700,000 liters. If 7 of you want to join him, we've neutralized the consumption of GPT-3. In fact, let me continue with that. That's about us, about 50 of us in the class. So we already consume more than GPT-3, the training of GPT-3. For sure, we can have, there's another number, which is 6 billion liters of water for the execution and this and that. But what's that? That's about 50,000 people. It's just a district in Granada will be comparable to that. Should we go there and we convince them to turn vegetarian, you can do that, then that's it. We've neutralized all the water consumption of all of the AI agents out there. So what do we care? Well, we still care. It's just that we don't know. Suddenly we realize we don't know the value of water. And I hope I convince you of that. The whole world consumes much more just because we eat meat. If we stop eating meat, that will go away. Okay. Now, there's many more things to say about water, which is water does not disappear. Energy does, but not water. It still is there somewhere, has a way. Okay. So these things are very important because we need to understand that. And today I'm going to do a very important quest, which is to understand the value of things. And in particular, I want to understand the value of water. And to do that, let me propose a measure. One way to think about the value of water is to say it's the price you pay. We can think the value of energy is the price you pay, right? Well, for energy, it almost didn't work because we pay a lot for energy that when we saw is practically free. In fact, if we analyze the value we get from the sun, what we see is that the price of the electricity was wrong to begin with, right? There's a way. So perhaps the perspective is the value of water is what you lose if you don't have it, right? Okay, so here's an equation. I'm going to give you a few equations. Don't worry. With these equations, I know that when you show an equation, it's a proven fact. You lose half the audience. Okay, don't look at the equation as just something beautiful to admire, not that I want you to fully understand it. It's just that I want to give you a framework. It's going to become very important for us a little later, because at the end of the day, as you know, if I'm going to be doing AI or I'm going to bring in agents, that's all they understand. They only understand equations, right? They don't understand pictures. So here's an interesting framework to understand the value of water. The value of water will be the sum of 5 things. One would be what's called the operational value, is the way water affects my revenue, right? For many companies, that's important. Another one would be the risk. The risk, which is what happens if I have a disruption of water? How is that going to affect my revenue? And that is really an insurance policy, so I have to treat it like an insurance policy, and I have to introduce some risk aversion. So there's a way to do that. I'm not going to explain these formulas. I'm not interested in the formulas. I'm interested in the framework of valuing water. There's also the regulatory aspect of water. Water is heavily regulated, and it does give rise to costs, as well as the fact that we have some strategic value in water. And now in the age of ESG, how I manage my water is an issue. And look, why was that paper written about the water use of GPT-3? Why? Because this is an issue, and it does affect what we do. I mean, for example, Apple knows that, and the way they design watches is taking these things into account. Why? Because people care. And finally, what I have is externalities. Externalities is the difference between the water I have now and any other alternative I may have. Like, for example, many of you are from the Emirates, where desalination plants are important and they add a cost to water. If you have water which does not need to go through a desalination plant, the price will be X, otherwise it will be Y. Or if you have to bring it by truck, that's an additional cost. So that's the cost of externality. So the value of water is complicated. Now, why am I talking about that? I'm talking about that because this is really what I want to talk about today. This is the 17 Sustainable Development Goals of the United Nations. I have them here. They are listed here, all 17 of them. You can see that the word water appears twice. Well, one is somehow life below water, and the other one is clean water and sanitation. I care about that one a little bit more. In fact, you could say that I've been talking about affordable and clean energy. That was how I started my talk today. And then you can say that I've been talking about clear water and sanitation, which is true, but also indirectly, I've also been talking about climate action. Why? Because climate action is driven not really by our desire to change the climate, it's by our desire to not change the climate. And we know that there's a very high probability that climate is changing because of the increase of CO2 and methane on the atmosphere and the way that those gases interact with the reflected sun radiation, not the sun radiation itself, but the reflected one from the Earth. So these are the things that I've been talking about. For sure, if I could come up with an alternative source of energy that does not produce CO2, that is going to go a long way towards the climate action objectives of, for example, the Paris Agreement. You understand what I'm talking about? So all of these things is what I'm talking about. However, let me say something else. If I have time today, and I think I will, there's one other thing that I want to deal with at exactly the same time, and that's to show you how important our techniques could be, and that is no poverty. It's actually the first Sustainable Development Goal. Okay, so I will talk, if I have time, about poverty, and I hope that by the end of my talk today you realize that the Agentic AI approach we can develop can deal with at least 4 of these SDGs. The reality is that I believe we can deal with all of them. But I'm talking about the future. I have to repeat that. This is your future, because a lot of what I'm talking about today is not really very well understood. And proof that it's not very well understood is what happened in Spain last year. On April 28th, Spain and Portugal had a nationwide blackout. Some of you suffered that, I'm sure. Okay. So let me talk about that. I want to use that as a business case. There's 3 business cases I want to do for you today. That's my first business case. And I want to talk about what happened and how it has to do with what we're talking about here today, and how to use an agentic AI approach to not prevent it, because we can never prevent these things, but at least to minimize the probability of that. So let me tell you, first I want to tell you what did not happen. There's been a lot of misinformation about this. So you'll know there was a blackout, even those not in Spain. It became very famous around the world, very famous blackout. By the way, I have to say it was not very severe, because Spain was without energy for about less than 24 hours. We had a similar thing in Toronto. From Toronto to New York, including Pennsylvania, and we were without electricity for 3 days. It was much worse. In fact, when I saw that happening in Spain, I said, oh my God, these guys will be without electricity for 3 days. And then I saw it was coming back very quickly. I have to say, I admired the operators here, because they were far, far better than the worst in North America.
I was 5 hours in the entrance of my house because I have no physical key to enter.
In New York, people could not go to the hotels because they couldn't open the door. They had to sleep in the parks. It was good that the blackout wasn't in the summer. Okay, so yeah, I mean, talk about sustainability, this is what I'm talking about. This is the future, okay? And this, so I want to make a reflection how these things can be avoided. But I am going to use the Spanish blackout because I thought many of you would be very intimate with it. Otherwise, I'll be talking about the one in New York, which if I was talking about this in New York, I'll mention the New York blackout, okay? Which I think many people were very intimate with it. I was stuck for 3 days. I was actually on my way to the airport to come to Spain. And I could not go to the airport because, that was 2010. I could not go to the airport because the taxi service could not operate without electricity. The cars could be driven, but they didn't know how to dispatch people because they couldn't contact them. So, and of course, airplanes could not fly. The airport was also without power. I could not even check with my airline if my flight was canceled. I just had to assume it was canceled. And 3 days later, we got electricity back. So, and then I could see that indeed my flight had been canceled. Okay, so, but let me stay with the case in Spain because it's closer to home and many of you went through that. So let me tell you what it was not. It was not a simple cloud. There was some cloud activity. In fact, it is known that one of the fastest changes from sunlight to overcast happened that day. So that was a factor, okay? But there were other factors. It was not a cyber attack, as it was very quickly hypothesized. It could have been. In fact, many of these systems, they are under constant attacks. Nuclear power plants are their favorite targets for, I suspect they're just hackers trying to train themselves. I don't think they intend any real harm, it's just that they do it for fun. It was not caused by renewable energies, although they did have a role, but it was not caused by renewable energies, as was also mentioned. And it was not only a control and system dynamics failure. It was actually a combination of many different factors. I have some of them here, okay? It was a very perverse combination of many things that just went wrong at the same time. I will get a little bit, I'll give you some information about this because it's important for my theory as to how we can remove these things from happening again, okay? All right, so to do that, let me start to talk about agents now. So what are AI agents? We all know how machine learning works. It's simple, it's fantastic, but it's very simple. We have some data, we have some output. What makes them different from agents is that in the agent world, we have a loop where we start with perception that goes into analysis, that goes into action, and then that becomes a loop that just never ends. So it's far superior to machine learning. So to understand how agents could play a role in a sustainable electricity grid, let me give you a business case. How would we use AIs against the Spanish blackout? So I have here a picture of 3 energy producing facilities. The first one is a water dam that gives rise to hydroelectric power. Hydroelectric power is very reliable. It does take a little bit of time to start, but not too much. It can start in a matter of seconds, really. And I'm assuming you know how the power grid works. The power grid consists of producers of electricity and consumers of electricity, and you need to have a near perfect balance. If it gets off balance by, say, 1%, the system will collapse. So you need to have a near perfect balance. That means that you can't just tell people to lower their lights or you can't communicate. You have to have a system that watches that and produces electricity on demand, sometimes very fast. So you have a collection of electricity generating systems some of which can turn themselves on very quickly. Some that, for example, gas powered. Actually, the combined, the combined cycle, gas combined cycle, or water. Those are very fast. Some which are very slow. Nuclear is very slow. There's not a lot of that in Spain, I believe, anymore. But nuclear is very slow, but it's very steady and very reliable, right? And then you have wind and solar, which is very fast, but very unreliable. You just don't know how much wind there's going to be, and you don't know how much sun there's going to be. By the way, there are agents being built to do very good prediction of sun radiance and wind because of that, because the systems depend on that. So what I'm talking about today is actually being built. It isn't fully built yet. So there's a bit of science fiction in what I'm talking about. But water is very fast. Wind is very fast too, but very unreliable. And sun is very fast, but even more unreliable. Well, unreliable in a different way, because we know that there's zero production of sun at night, whereas there is wind production at night. However, we could go days without wind, but we are not going to go days without sun. So their stochastic factors are different. And then on top of that, smart systems now have storage facilities. You can have very high performance batteries that you can use to accumulate energy. And all of this can be orchestrated to help us manage that very delicate balance between the voltage and the frequency. Perhaps something important here is that the difference between water, hydroelectric, or nuclear, or gas-powered, and what's called renewables, which is solar and wind, is that the energy that's produced by the traditional ones is energy which is produced in Spain at 50 hertz. Whereas the one produced by the sun is not produced at 50 hertz. You have to use inverters to send it back into 50 hertz. And that means that the one which is generated mechanically, you have these huge turbines which are rotating at the speed of 50 hertz. They're very heavy. And that gives a lot of inertia to that system, whereas that inertia you do not have in the world of renewables. It's produced artificially. That means that it's a lot more delicate. You don't have any physical control variables that you do have in the world of the physical one. That means that when we are trying to understand how all of this can be put together, when we're dealing with renewables, we have little to no physical inertia. And that makes us much more reliant on software controls. So that's one area where agents are going to start to play a big role, okay? And because at the same time, what we have is, in the case of trouble, you are disconnected from the grid. You cannot, these problems have a way of cascading from one territory to the next. So the energy grid has been designed with tripping points that will disconnect any area that has trouble to protect the rest. What happened in Spain is that all of this tripped in sequence very quickly, one to the next. France managed to isolate itself from Spain. I believe the origin of that cascade was in southern Spain, so it took maybe a few minutes before it got to France, and then France managed to stay safe, not Portugal. I think Portugal was instantly collapsed because of that. So you need agents that monitor. Yes, that's my understanding. But I learned a lot about the Spanish energy system preparing for this class. Okay, I knew about this, but I wanted to give an example which was from here, so I decided to learn a little bit more about that. But the situation is that what we need to have is a real-time observation agent, which we don't, that manages not just these two aspects of the global grid, but many more. Okay, I'm just mentioning these two so that we understand. And so this is my introduction of AI agents. That's what they do. And in this particular case, they would be designed to minimize the problems we could have from all of those things that gave rise to the Spanish blackout, which you cannot avoid. These things happen. These things happen. So there's 4 types of agents. You have reactive agents. We have planning agents, learning agents, typically developed with reinforcement learning, and multi-agent systems. All of these will be used in I'm going to design for you an AI-driven agent to manage the Spanish power grid. That's what I'm going to be doing in front of your eyes. Okay? Science fiction. In fact, some of these machines don't exist, but my hope is that some of you do it. And then when you do, you send me an email. Okay? I want to know about that. Yes? Okay. So that's the science fiction I will do today. I want you to do that. All right, so let me start to tell you how this thing will be built. I want to build it for you. I start with my data inputs. I need to have data inputs so that I can feed my agents. So my inputs are going to be of different types. My first one is going to be electricity demand. How much electricity is being used by my consumers. And that changes very fast. So I need an agent that watches that more frequently than every second. That's a data input. I'm gonna need it. I'm gonna have a solar forecast. Because that is gonna tell me my solar farm's production lines. I need to know that. So I will have another agent that's gonna be managing that. I will have a wind forecasts. There's going to be data that's going to be feeding another system. I'm going to have another data input, which is the hydro status, the amount of water in the different dams, in the different reservoirs, and a turbine availability. I'm going to have information about grid conditions, frequency, volume, how close I am from reaching a break point. Market data, prices, how much, electricity is produced and paid for in a very unusual way because there's an auction mechanism that happens. And very often it's done the day before. So I need to understand that. And different agents produce electricity at different costs, but I pay them the same, sometimes not. So I need to understand that. Because, I'll mention this now, these systems can be very perverse because forget about the AI agents, the commercial agents, they all have their independent objectives. And for most of them, it's just profit. They don't care if there's a blackout. In fact, many of those commercial agents would probably be very happy if there's a blackout, if that increases their revenue line. So we need to be aware of that. If I'm going to build an agent that is going to minimize the possibility of a blackout, I need to be aware that some of the agents I'm going to be working with may be working against me. So I need to understand what their objective is. And by the way, this is going to become a very big exercise in game theory. Okay? But before I get there, I need to have the data because I may have to predict what that perverse agents may be up to. Okay, so that's going to be part of my agent too. I need to know about market prices, price bids, and constraints. And I need to know about alerts and events. Because sometimes, blackouts happen in tiny areas in a normal way. So I need to be aware of that too. And these things these are data sources that I need to have in real time. So that's my data source. Yes?
What do you think should be the time horizon forecast? So to be able to manage the whole thing, you need to be able to predict stuff.
Yes.
So should it be enough with 24 hours?
With 24 hours, you have a lot of response time because a lot of these auctions happen on a day-ahead market. So if I know I'm going to have an issue, say 2 days from now, for whatever the reason, increased demand, a very big soccer game, Champions League or something, or whatever, I'm making this up. If I know something is happening more than a day ahead, I can increase prices, and then I know that the commercial agents will react, and they will make damn sure that at those prices I can deliver. So money is a very important element in my decision. In the day-ahead market, in 24 hours, my ability to change the price is very limited. But over a day, before the auction for the day-ahead market happens, I have some control. So 24 hours is critical because of the way the market works. Okay, electricity is almost is sold almost is sold on a futures market, and that's a 24-hour. So that's why 24 hours is typically a very important time frame for my data inputs and my decision variables.
And to an extent, what is actually predictable, right, in terms of weather forecast?
Yes, exactly.
Over 48 hours?
Exactly. Although, you know, when we have Thorsten Heffler telling us how he can do, you know, fantastic simulations, then that'll be great. You know, but again, I have lots of very smart people in the room. You guys can predict the weather 5 days in advance. I have no doubt. So go for it because they can be part of my prediction database. Okay. So this is just my my data. This is the part of the anatomy of the AI agent design which deals with the data. Now, once I have the data, then I can start to design specialized agents. These are specialized agents that only deal with certain aspects of the grid. So I have one which is my hydro agent. This is my agent that knows absolutely everything about water. Absolutely everything about water. And it has the ability to turn turbine dispatch on, off, control the volume, all of that. That's my water agent. Now, this is a simplified picture because I don't know in Spain, but I suspect you have different commercial producers of hydroelectric power. So, and the thing is that my agent doesn't really control it. The commercial agent will control it. So sometimes I have to control this with a remote control. I have to change some conditions so that my commercial agent that goes against me will actually incur into those actions. So what I'm showing you here is a very, very simple case where I have complete control over everything. It's a very simple case. I have complete control. So I can decide when to turn the turbines on or off. I will have another one. This is my wind agent, the one that knows the wind parameters everywhere, knows the availability of the turbines, the wind turbines. It knows the different set points of the turbines, and for example, knows if they're already spinning because they take some time to start. Knows everything, and knows everything not just in one location, in all the different locations and the different relationships between them. Then I will have another agent, which is my solar agent, and knows everything about every individual panel, the situation of my inverters, everything. Then I will have another one, which is my storage agent. This is the one that knows the capacity of my batteries, how much space is left, what is the space that remains, and the response time. So these are the individual agents that I have. And then I will have another agent, which is my risk and safety agent. Knows everything about the situation of the grid when I'm approaching the situation of danger, and it may be able to trigger preventive actions. So this is I only have 5 agents. This is a simplified system. But with this, we get an idea of how we can develop that. Now, with those agents, I can now think of a coordinating agent, the one that manages all of them. The storage agent, they're all here, and now I have my coordinating agent. Now, this coordinating agent, I have to say it's very important that I think of it because there's two ways in which the agent could work. It could be a controlling agent in which every other agent does what I say, or it could be a subordinated agent. I'm just at the mercy of some of the other agents because they are run by commercial companies that will do whatever the hell they want to maximize their own revenue lines, or a mix and match. So this coordinating agent is very tricky to design. In this case, it will be easier because what I do is I just optimize a certain function. But in this one, I have to coordinate, which includes a very interesting characteristic for the agent. It has to negotiate with other agents. If I want you to produce, and an object will only produce at a certain condition, not because I'm going to have it, you don't care about my blackout, what do I do to encourage your production? They have to be that smart. And this becomes a problem in game theory. This is optimization, that's game theory. And it could be a very complex game theory. So from that perspective then, I can now start to organize my agents to provide defense against the blackout, and the diagram will look like something like that. Okay. Now, when you're here, it could be I told you we're going to design this, and now you go ahead and if you need some funding to start your startup, tell me and we'll try to help you, okay? But this is how you would eventually minimize the risk of a blackout. And to a certain extent, what I suspect you have in Spain now is a version of this that involves maybe some AA agent activity, but most of it I think is done by humans, sometimes very slow, and sometimes making mistakes. In fact, I read very quickly, so I'm not completely sure about this, that at some point one of the problems with the blackout is something had to be increased and it was decreased by mistake. Okay? So that's typical human error. So if you can design a system like that, then you'll be safer. Now, to measure effectiveness between, and I suspect you are experts in this, I'm not, but there is two ways of measuring the effectiveness of agents. One is measuring the effectiveness of the agents itself, and the other one is measuring the effectiveness of the agents working with each other. And this is a very complicated, for me, maybe very simple for Paco, you know. But this is one of the areas where you need to develop this because these systems are still to be designed, okay? Okay, so I've talked about Spain, but then I thought, why don't I see how I could use this to design a project for the Emirates? So I came up with what would it take, and I'll try to do this quickly. I don't want to bore you. I want to talk about money from a different perspective also in my mind. But let's say that I have a project, it's called Desert Power, and I want to create a solar and storage project in the Emirates. What would I need to do that? It's very different from Spain. So first I found some inspiration from some existing projects that you have there. And some of them have battery backups, some don't. But the Emirates is very interesting is that the sun radiance is far greater than in Spain. So that changes that part of the equation. There's not a lot of hydroelectric power that makes the system grid different. So how can we do that? So I came up with this idea, and I'm just gonna, if any one of you in the Emirates wants to develop this, tell me, I'll help you, okay? That'll be fantastic. You can create a very interesting power plant. It's one that's gonna last for 25 years. I wanna build it, say, in Abu Dhabi. I don't know why I came up with that number. Probably Abu Dhabi is the wrong place to do this, but why not? Okay, solar capacity of 50 megawatts, And I'm going to have a battery storage of 250 megawatts that is going to give me megawatts for 4 hours. Okay, so that's going to have that's my storage capacity. How would I build it? So in building that, and this is a commercial build-up that I'm going to do. Okay, just to show you how agents could be used also for something like this. So the first is my generation profile is very attractive. It's about 25-30% higher than Spain because we are in the Emirates. So I have very nice production capability. The consumption profile is also simpler. A lot of the demand is going to come from air conditioning, which peaks in the afternoon and in the evening. Okay. So I have the agent that monitors consumption is going to have an easier time knowing or predicting where consumption is going to go. I'm going to have a total capital expenditure of 400 million euros. I chose euros. Sorry, I should have used Emirate dollars, but I use euros for consistency with the rest of my talk. Most of which goes into the solar panel, but a lot of that goes into the battery deployment. And then I would have a production profile with a capacity factor of 27%. That means it's going to produce energy about 27% of the time, with an annual output of just over a million megawatt hours per year. So with that, I would have a very nice project that's going to generate a revenue of about $35 million per year with an investment of 400 million. And that's going to give me a very attractive investment. It gives me about 10% return for 25 years. So what do I need to do to make it happen from an AI agent perspective? Let me think of the AI agent perspective. So for that, I need to create different types of agents, and here they are. My first agent is one that is going to be my forecasting agent. It's going to forecast for me the sunstorms, the sun radiance, humidity, temperatures, knows everything about the atmosphere. I have another one, is my grid stability, knows the status of my grid, knows the status of my batteries. I have another one, which is my solar agent, knows about the status of my inverters, knows about the voltage regulation. I have another one, which is my battery storage. This knows everything about the situation of my batteries. It can provide millisecond response to changes in the grid. I have my gas plant agents. I have gas-powered supply as a way to balance my voltage. I need that. I need a fast response. So in the Emirates, I thought gas. I cannot have hydro. So it's going to do nothing when there's lots of sun, and whenever there's a variability, it will power. It'll start my plant very fast, very fast. The response time it should be under 30 seconds. And I have my demand response agent. It's going to know and predict what is the different consumption profiles I have from my grid. And I will have I made an assumption, sorry, this is a bit foreign. I thought I would link, or I would have a consumer of my grid, which is a desalination plant, which is great because it helps me get rid of my excess energy when I have it. Okay? Sometimes you have excess capacity. When you have excess capacity, what do? You have to throw that electricity away. So I forgot to mention that, I linked my project to a desalination plant so I can use my excess electricity to desalinate water. and that is not part of my CapEx calculation, by the way. That will only increase the profit of that. So, but that's what I would do. And then I will have my market dispatch agent, also an agent that is going to act autonomously. And at the end of the day, I end up with something similar to what I had in Spain. This is my AI agent architecture that will manage that project for me. Anybody wants to start this? Well, that's how you would do it, okay? Now, I'm going to go into the last stages of my conversation now, and I want to talk about the other SDG that I mentioned earlier, which is poverty. And because I have some important things to say. This is an area, this is actually, I'm going to talk about a business case which is real. It's actually delivering this already, okay? Without the use of AI agents, but this is something that we intend to do. And the business case that I'm going to be talking about here is a foundation. Savinco is a non-for-profit organization, Savinco. Savinco is the way you say it in Spanish. They started in Ecuador, so it's a Spanish name, but Saving Co. You should add a G to the name, and they'll give you a better idea what it means in English. Saving Co. It's a corporation for saving, micro saving. It's a wonderful project for micro saving. I have a video that I'm going to show you that explains, the video is a bit misleading. I'm going to show it to you still because it'll give you an idea, but then I'll tell you what they do, okay?
Transparency and precision are essential to us. Thanks to our technology, we have been able to translate these values into our credit and saving groups. Here is how. After a group meets, the advisor who led the meeting inputs all the information into Savinco, our app for managing and organizing all members' finances. The advisor registers any new changes into the app and provides a summary of the meeting, including any training given or decisions made. As soon as the advisor saves the information, it is then reflected on the app that all members have access to. Savinco app. On Savinco, members can see their own information in addition to their group's information, their meetings, and much more. The most basic elements are the accumulated savings, loans granted, profits received, profits pending to be received, credit capacity, the next meeting or any upcoming payment. Savinco app is an entire world, and so it will be further explained over the course of some shorter videos. It can function on both computer and phone, it take up little storage, can be used offline, and allow for multiple profiles to be registered. Saving is now easy. Get Savinco app and control your finances.
So this is you're probably familiar with the microcredit development that got UNUS the Nobel Prize, the Nobel Peace Prize. You're probably aware of that. And Grameen Bank that developed that business, I'm not sure. Okay, well, this is different. Okay, so I'm not, this was a fantastic initiative of the Bolivar family, friends of mine, who what they did is they developed the concept of micro savings. Let me explain that to you. I believe I have it, yes. And then you will see how powerful AI agents could be in a different part of the SDG chart, okay? So this is a digital platform which is dedicated to improving the financial literacy and decision-making of people. They were targeting the poorest of the poor, people for whom an objective was to save like $1. That was the objective that they stated. But to do that, they decided to start by educating people financially, explain to people what savings is and explain to people what interest rates are. And they did that by providing some financial education, all mobile driven. Everybody has a mobile phone, even poor people have a mobile phone today. and introducing behavioral nudges, encouraging to save and to budget. And they created an array of financial services with a mission to enable people to understand their money, understand the concept of their money. I have a graph here. The problem they're dealing with is that there is very low financial literacy globally. And people make poor decisions in the area of savings, in the area of insurance, in the area of borrowing. Okay? And the consequences is the debt trap. In fact, one of the criticisms of the micro loan business is that it traps people into a credit cycle that they cannot get out of. What they did is they did the opposite. They encouraged people to be trapped in a savings cycle that is going to become very profitable for them, and I'll explain. It's a very good idea. Anyway, so that's the move quickly to. I'm going to move to. Okay, let me show you an example. Imagine I'm a borrower. I need $10. I'm a fisherman. My fishing net broke. I need to buy a new one. And without the fishing net, there's nothing I can do. So I need to buy a fishing net. And I don't have $10. And this is a real case. So what I'm going to do is the system is going to help me find two lenders, people who have $5 who are willing to lend them to me. Okay, do I have anybody willing to lend me $5? Okay, well, the thing is that you don't know who I am. Okay, but when I do this within a community that is typically built on trust, these things tend to be doable. And trust is a very big element into this. And the way it works is the system is built not so much on the borrowing, but on the lending. Because let's say looks extreme, but it's wonderful. Let's say that I borrowed the $10 and I'm willing to pay 10% per month. Now, 10% per month is a huge amount of money. Okay, it's at the loan shark level. But the thing is, the ones who will lend me the money or the ones I pay that interest to are members of my community. And if I'm a fisherman and I need a net, okay, so that's my cost of doing business. I pay 10% per. It's a huge amount of money, but the money goes to the lenders. And once the lenders understand what that means, the fact that if you have $5, you're going to make 50 cents per day. That's fantastic. You just need to understand it, right? And so this developed maybe 10 years ago, a long time ago, 10 years ago. And then the result is fantastic, because then this Savinco, who manages all of this, they collect 10% of the 10%, which is a huge amount of money for them too. But the people who are earning 10%, if you make 9% instead of 10%, you probably don't care very much. And by the way, I'm making the 10% as a mythical number. It's probably something around that area, okay? It doesn't matter very much. But this is the magic diagram that makes these things work. And just to give you an idea of the magic here, we're talking about people where they would borrow $10. Okay, not like the $300 cap for the micro loans. That's too high. I borrow $10. That's all I do. And this has been done with real cash. It has been going on for 10 years. And then the people in the community get together, and people do the lending and the borrowing, all in the same table. And the amount of money that sometimes these things have grown into this village is that in that table, in that one day when they do the exchange, up to $100,000 have been exchanging hands. And the numbers that they have grown to are now this. These are the volumes they've managed to build with $10 loans. It's fantastic, it's really fantastic. And it has managed to get people out of poverty. And so this is the business case that has been done. Look at the amount of borrowed capital has been over $300 million. This system works, okay? But it's been working with physical money, it's been working with physical operations. what I wanted to do is I wanted to introduce this into our AI agent situation and see if I can develop an AI agent system that will manage that for us. And the answer is yes. So I'm going to go through that quickly. I want to end my talk. I want to end in 5 minutes. My religion does not allow me to go over time. You know that. Okay? And I want to leave some time for questions and maybe discussions. Again, this is the future. Talk about the future. The future is you. So we're going to be the ecosystem of agents is very similar to the previous one. I'm going to have my agents that deal with the inputs, which is going to have my spending patterns, my income. I'm going to have my agents that deal with behavioral data. They need to understand how I like to save, how I like to spend money, what my risk preferences are. I'm going to have my contextual data. It's going to tell me about the local food prices, the price of rent, the price of the things that I need, inflation, economic. It's going to have the financial systems data. This is like the Bloomberg for the poor, right? It's going to tell me about insurance products, market liquidity conditions. It's going to everything that, and this is my agent. This is taking care of all of this. This is the information about policy, social data, access to help, access to social programs, regulation and compliance, and all of this is my agentic AI inputs. Once I have that, then I have my coordinating agent. As before, the coordinating agent is going to provide me with the optimal welfare from my financial situations, and it's going to have at the core, it's going to optimize the usual welfare and the financial sustainability, with different objectives which have to do with financial resilience, reduce over-indebtedness, increase savings, align decisions with long-term being, and support SDG outcomes, if it's sustainability that I'm interested in. So this is how the coordinating agent with my input, financial input agents would work, and then I would build specialized agents, my personal finance agent, my credit agent, my risk and insurance agent, my investment savings agent, truths and ethics agent, and my impact agent. All of these would then interact with each other to what's called the control outputs, which could be taking financial decisions, credit decisions, behavioral nudges, risk mitigation, and so on. All of these are things that can be developed. They haven't been developed. They can be developed, and I thought of Savinco as the wonderful platform on which these things could be delivered. And then this could be built into a physical system, into the real world impact AI agents that would take that and be acting for the service of households, individuals, and developing essentially is a shadow financial institution. Okay? And the outcome of that is what we achieve, which is financial well-being, improved decisions, long-term sustainability, and the development of trusted circles. And this is then built into a continuous learning loop where I learn to my agents learn to optimize the recommendations, to execute actions, and to measure outcomes. So the app that you saw earlier, which is one of the apps that Savinco promotes, can be completed with an AI agent behind the scenes that would take care of the well-being of their communities, and that would be what it looks like. Okay, and I want to end. I'm just going to go to make that statement, which is in a social fintech. I call this social fintech. In a social fintech space, the risks that we are dealing with, the financial risks that we have to deal with, have a combination of money elements and human elements. Therefore, the risks are very deep. And this is a way to deal with that. And to end, I just show you other applications where these things are now being deployed. One is on water allocation, precision farming, traffic, and waste management, okay, which are, again, related to some of the other SDGs that I mentioned. And with that, I end my talk. Thank you very much.
St. Louis, please. Comment? You have comment question? I? Okay. You first, please.
Yes. Very, very interesting talk. Thank you. So I was wondering, how much is data a problem in building these systems in that environment?
So a lot of the data that that we need for, I mean, okay, so on the electricity area, a lot of the data comes from sensors, which is being developed. This is the large multimodal models. They're beginning to be developed, and there's a lot of activity, especially in China, in the creation of these sensors. Right? In the area of finance, which is what I'm mentioning here, the reason I like to bring up Savinco is because they have all the data. They've been doing this for 10 years and collecting data before they knew that AI would be coming and that something could be done with that data. It's one of the areas I would like to, help improve. But the data is developing, but in the electricity area, there's a lot of that already, because this is how these systems work, and the data has been collected for a long time. And I know, I don't spend my time on that, but I know that on there are agents which are being created to forecast sound cover, a sun cover, cloud cover, wind direction, wind speed, and we have very good databases for that now. And we also using satellite images. Google is one of the biggest owners of a lot of this data, but it's still being developed.
Thank you for your talk. I think it was fun, this collective dream about managing the Spanish electric system with agentic AI. But in the short term or mid-term, at what scale do you think it would be possible? Or it is now possible to apply it in some region, or just in some steps, or it was just a dreaming?
Well, I wanted to use this as a way to explain how AI agents would work in a practical case, not in an abstract case. So I had to make some assumptions. Okay? And I spent some time going through what happened on April 28th of last year, trying to understand what gave. And then it occurred to me that this is a very good example of something that I believe could be done. I believe the data is there. Back to your question, I think for Spain, for the Black Card, I think the data is there. The agents, I think, are not there, but I don't think they're very hard to develop. They should call you, and then you can do it for them. So this, I think, is very doable, and that's why I liked. Actually, that's why I chose to talk about that.
Yeah, but I think that in a practical way, it will also be other problems such as, I don't know, the security, or as you said, the different companies.
Okay,
so it will be almost impossible, in my opinion. Am I right?
So these agents, for Spain, they would not be agents which are controlling agents. I cannot tell you, go and do that. You will do that if it. But again, my understanding about the Spanish market is very oligopolic, meaning there's only a few players who participate in the market, and they participate according to very well specified revenue outcomes. I don't know how much freedom the government has to create new laws to change the behavior of those. Okay, so I'm assuming none. So what I have to do is, and that's something I did not discuss here, I have to understand the game that consists of the electricity producers, which will act on their own benefit perspective, how I would change the price, for example, or the auction. No, the auction mechanism is the same. The auction mechanism cannot be changed. But how I would play with the different players so I want the outcome I want. So I know the outcome. That I can know. The question that I did not address is how, and I do not know how to do, I don't know enough about the Spanish system, is how do I design the game so that I do the actions that give me the right response from you. That will be the part that needs to be modeled, understanding the different players, and needs to be designed. But the advantage of Spain is if I understand correctly, I don't know much about Spain, okay? I do speak Spanish, I was born in this country, but that was a long time ago. And since then, but my understanding of Spain has a tremendous advantage that you have a tremendous price flexibility. I believe electricity is very cheap here. So that gives you a lot of variables to play with, to work with, to prevent these things from happening. That's what I believe. So I suspect there will be a solution. I suspect. But I leave it to you. This is your future. Yeah? Yes.
Thanks. But I have any other question? Or the last one for me? Okay. I have a question. Thinking in the use case in Abu Dhabi, or even in Savica, how many uncertainty and how many deterministic behavior have the mass? What is the real the balance between the uncertainty and the deterministic behavior of the agent? Because Savica seems deterministic.
Very deterministic.
Yes.
Very deterministic. Yes.
In the case of Abu Dhabi use case, of course, you need to take a decision about the use of electricity and the demand change, and then you have the option of the water production.
That's right.
And then you know in some way how to take the electricity. Then what if, let's suppose, because I am thinking that for a classical agents, multi-agents system, classical platform or structure may run. I don't know, can you need, for example, LLMs supporting, generative AI supporting, in order to take more high-risk decision?
I think for this, no. I think this is easier. I think for this, no. If I understand correctly, and again, I made up this example. This is not what I do on a daily basis, but it was fun to do. The thing with electricity production is the accuracy that you need. You need to have a very, very small, I believe, like 0.01% deviation between the output and the input. Otherwise, your frequency collapses. So you need an agent which is very accurate in managing that imbalance. But this cannot be very difficult because this is already happening without the agents, right? And the case of blackouts is very rare. So that's why I suspect this would be a way to enhance the profitability of these energy projects, because it will help you increase their reliance on the cheap electricity production, which is how I started with, is solar. Solar is the cheapest, right? Then you can rely more on that, because the better agent you have managing the problem solar gives rise to, which is the lack of a physical frequency, then the cheaper the electricity production would be. That's what I think. So I think the use of very simple agents will help shift the burden of power production from the easy, expensive ones to the challenging, cheaper ones. That's what I think. So this is, if this was to work, it would change the power production away from fossil fuels, which is very expensive, and but problem-free, into the renewable energy space, which is very cheap, but has physical challenges. That's what I think. Yes?
Just a question. How do you think that use... Thank Thank you for the great presentation. I have just a question. How do you think that the agents will help in the RD, in the sustainable, in the energy storage, in discovery, like materials that can save the energy? Or
Okay, so I think the agents, at the end of the day, what they would do is they would turn our overall system into a more efficient one, cheaper also. Okay. I don't think you need them to run this. These things are already happening, right? Spain has a 50-60% renewable energy production and has very low electricity prices because of that. And in the Emirates, you have all the power you need. So this is not needed, but this will enhance the efficiency. It will drive the consumption away from fossil fuels and to cheaper energy sources. So we win both from the climate action perspective as well as from the financial perspective. So agents would become money makers, okay? Which at the end of the day, if you want something to actually be adopted, it has to lead to financial gain. It's very hard to convince people to do something that's going to make them poorer, right? And that's why I like this approach, because it will lead to financial gain, substantial financial gain. And of course, my dream is how I started, free, unlimited energy, right? But you need agents for that.
thank you very much.
Any other comment, question? Okay, thank you very much. Please.